Alright, hello everybody. Um, Today's video is going to be about the periodic table. And I know we've already worked with the periodic table, um, done quite a few things using the periodic table, right? But what we haven't done is we haven't really talked about why the periodic table is the way that it is and how scientists know that it is the way that it is. And in fact, at the end of last week, there were several people who brought up really great questions about, why is the periodic table shaped the way that it is? And so that is what we are going to get into today, okay? Today's video is going to be a little bit of an introduction to an activity that we're going to do in class at the beginning of this next week. Okay, so the objective for us for this lesson is for you to be able to describe the patterns and features of the periodic table, okay, from a scientific perspective, right? And so you're going to be able to do things like the following. You're going to be able to explain why the periodic table is shaped the way that it is. You're going to be able to explain why elements in the same group or column on the periodic table have similar properties to one another. And you're going to be able to use patterns on the periodic table to determine the electron configuration of an element. Okay, and so we've been working with electron configurations recently, and it can be a very tedious process, right? And so what we're going to learn through the course of this lesson is how we can use the patterns that we discover on the periodic table to make our lives a bit easier in that regard. Okay, so you may remember a video in the not so distant past where we were talking about a really old dead scientist guy. Actually, he wasn't really a scientist, he was a philosopher. You remember I'm talking about Democritus, right? The ancient Greek philosopher who is credited with the invention of the idea of an atom. We're going to do a little bit of a similar thing here today where we sort of tell the story of a old dead science guy and this particular person is important because he did a lot of work with the periodic table. So his name is Dmitry Mendeleev. He's a Russian chemist and inventor who was alive during the 19th century. So that would be the 1800s. He actually did survive until I think 1907, but he did most of his work obviously during the 19th century in the 1800s. His most notable contribution to the field of chemistry is his work on the periodic table and his recognition of periodic trends amongst the elements. And he was also involved with petroleum and petrochemicals. So you may or may not know that Russia, their primary export and how they make a lot of their money in that country is through the oil business. And so Dmitry Mendeleev was fundamental there. He helped to establish the first oil refinery in Russia. Okay, so based on his research, Mendeleev produced several different versions of a periodic table. And while he wasn't the only chemist doing that type of work at the time, he is famous for one particular thing, and that is for his predictions of future elements that had yet to be discovered. Okay, so as of 1863, there were 56 known elements, okay, so that had been discovered and sort of accepted by the scientific community at the time. Mendeleev recognized periodicity in many of these elements. Periodicity means like repeating patterns and similar properties amongst groups of elements, okay? Because of his understanding and recognition of periodicity in these elements, his periodic tables were a bit different than some others. They left open spaces for elements that he was certain must exist, but just hadn't been discovered yet. So he was sure that they were there, they just hadn't been found. And I have a picture of one of his periodic tables. This particular one is from 1871, and it's a bit disconcerting. It doesn't quite look like the periodic table that we are used to, but you will recognize some elements here, most notably hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, right? So those are going in the same order that we're used to seeing on our periodic table. Then you go on to the next row, right? Sodium, magnesium, aluminum, silicon. So he definitely had things arranged in the right way. Things get a little bit hairier down here. And in fact, these numbers that you're seeing here, these are actually not atomic numbers like we're used to. Keep in mind, this work was being done prior to the discovery of protons, neutrons, and electrons. Okay? So Dmitry Mendeleev had absolutely zero knowledge of subatomic particles. All the chemists that were working at this time knew that different elements existed, but they didn't know what they looked like in terms of their structure. So they were really just working with different chemical compounds, like when the chemicals react with like oxygen and hydrogen, for example. And so these numbers here are actually the atomic masses, which was a lot easier for them to measure and work with at that time. So I've got one particular spot here circled. Actually, there's several spots that could be circled. You'll notice that a lot of these places have element symbols, right, like nitrogen, oxygen, fluorine, along with the atomic mass, which for the most part is accurate. Several spots have a dash where the symbol would be, and those are some of the spots that I'm talking about. Mendeleev noticed that there were blank spaces, right? When he took all of the elements and sort of lined them up according to their properties and this periodicity, the patterns that he was noticing, there were empty spaces. And he was convinced that there must really be elements there. They just hadn't been discovered. And this one right here is of particular importance to me personally. I really like this story. So that's the one that we're going to talk about. Okay, and it's for an element that has an atomic mass of approximately 100. He wasn't quite right in that prediction. It is for the element technetium, okay, symbol Tc. This is atomic number 43 on our periodic table. I consider this to be his most notable prediction because this element wasn't discovered until 30 years after his death. So he first predicted this element's existence in around 1871, right, when he produced that periodic table. He died 36 years later, and then it wasn't until 30 years after that that technetium was synthesized and discovered. Okay, and I think this is particularly interesting because technetium is a special element, okay, and I'll talk a little bit more about that here on the next slide. So here's our modern day periodic table. This is actually the one that we've been using in class. One thing I want you to notice is that most of the elements on here, especially in sort of the top half of the table, have atomic masses, right, or we should say average atomic masses, right, that we've learned how to calculate, that have lots of decimal places and decimal points, some more than others, and that's due to the presence of these different isotopes, right, that exist, the different versions of those different elements. Well, technetium has got something going on that's a little bit different here, right? You see that? Its mass is in parentheses there, 98. That's not the only element that has masses in its in parentheses. There's other elements that do as well. Okay, you'll see a lot of these down here on the bottom row, a few right here, several of these down here in the very bottom section. Elements that have a mass like that are unstable, okay? And what that means is that if they were to come into existence, if an atom of that element was to exist, it's unstable and it will radioactively decay over a certain period of time. So, but in essence, it will not disappear, but it will transform into something else. It will give off a proton or give off a neutron or some other form of radioactive decay, which we will learn about later in the year, and it will turn into something else. Its nucleus will turn into some other element. So, the weird thing about technetium is that it is by far the lightest element that behaves this way. Okay, so you'll notice that technetium here, number 43, has a mass of about 98 here, or it has a mass of 98. That's because the only version of technetium that we've been able to observe is technetium that we have created, humans. have created technetium in labs, and it has this particular mass, so that we've been able to make like one isotope of technetium. All these other elements that are smaller and bigger than technetium exist naturally, but for some reason technetium doesn't. And then you have to go all the way up to polonium, astatine, radon, etc. to get to these elements that had to be artificially created. The reason I think this is so interesting is because it took a lot of scientific gusto and courage for Dmitry Mendeleev to, put his foot in the sand and say, I think that this element exists. Why do I think that? Because I've noticed the patterns and periodicity in all these other elements that exist. I'm certain that there should be an element here. I'm going to leave an open space for it, right, on my table. There should be an element here. We just haven't found it yet. And several of these other elements were found, during his lifetime. But this one, he predicted, and he ended up being right, but he never knew about it, right? Because he died 36 years before it was discovered. So I just think that's a particularly interesting situation. So what we're going to do in class, so hopefully you're watching this video in the weekend before, right? What we're going to do in class is we're going to do an activity where we take a look at the periodic table, and we're going to look at the electron configurations of these elements, okay? And we're going to be exploring why the periodic table is the way that it is, the shape that it is, and sort of what was going on that enabled Dmitry Mendeleev to be able to make this prediction, right? He was correct, right? So what is fundamentally going on in the nature of atoms that enabled Dmitry Mendeleev to be able to make that prediction, okay? So hopefully you guys are having a nice weekend. I will see you guys in class on Monday or Tuesday, and see you then.